Okay, as we look at this question here, we start with a particular question, the starting question here. And can you see that we're changing into a common denominator? We're making them into tenths. So we are making the common denominators for the two fractions. And then into the next one, we are literally just simplifying, rewrite the fractions after multiplying by 2 and 5. We're simplifying things there. And finally, we're adding the two fractions together. So that should be DAC. And now we're going to try and employ the same technique with this question, right? So we start with two fractions with different denominators. And so we are going to try and make them the same denominator. So I think the step here is we are making, or maybe it's not making, maybe it's rewriting using same denominator, right? Same denominator. Okay. And now what we could do is we could then finish this off by rewriting with the same denominator. So just copying it out. And of course, let's do the numerator. That's 2 root 2. Root 5 times root 2 is root 10, plus root 5 over root 10. And so it is just 2 root 2 plus root 5, and that's over root 10. And that's a fine final answer. Of course, you could be fancy and rationalize the denominator, right? And if you took it a bit further, you would have to times the bottom by root 10 and times the top by root 10, and that would give you 2 root 2 root 10 plus root 5 root 10, and that would be all over 10. And there would still be a bit of work to do here, right? So let me just put an extra page in so I've got space to do it. Let me just go back here. I'm going to go and grab this little guy now. Now, don't forget the previous answer that you've got is perfectly fine here. It doesn't tell you that you have to rationalize the denominator. And if we follow the same steps as the regular fractions, you would certainly end up with this answer, and it's a good answer. But let's just take it a little bit further just for fun and have a look at what happens to it if we keep going and rationalize the denominator. So let me go and copy this. Copy. This is copyright. Oops, I need to cut it. There we go. And now paste it on here. Paste. Okay, so we want to simplify the surd as well. So this is 2 root 2. Instead of root 10, I'm going to change it to root 2 root 5. And this is root 5 times root 10. Instead of root 10, root 5 root 2. So it looks a bit crazy, right? But I think this is the easiest way. And now look, we've got 2 for this guy. And then we've got root 2 times root 2, which is another 2. Then times root 5. And in a similar way, can you see that root 5 times root 5 is 5. And that is over 10. And now I have 4 times root 5 plus 5 times root 2, all divided by 10. And that would be your final answer. Now, it's interesting that you could have actually got to this answer in a far easier way if you'd have gone back to the start and actually tried to do this in a slightly different way. And I'll just do it on the side here. So we've got full version here. What if I actually didn't follow the pattern that I had here? What if I actually decided to evaluate these two fractions by, first of all, rewriting this 2 over root 5 by rationalizing the denominator first? Can you see that would be 2 root 5 over 5? What if I get the 1 over root 2 and I rationalize this denominator? That would be root 2 over 2. And now the question I would have is 2 root 5 divided by 5 plus root 2 divided by 2. And can you see it might be easier now to change these both into tenths, right? So I'm going to go into tenths here, this one into tenths. This one I've times by 2, so times the top by 2, that's 4 root 5. Oh, this looks a lot easier. Times this guy by 5, therefore times this guy 5, that is 5 root 2, and look at that answer. 4 root 5 plus 5 root 2 divided by 10. Just check on that previous answer. Exactly the same, but look how much quicker it was, right? So I think it emphasizes the point, doesn't it, that if we have a fraction addition and if the denominators are surds, it definitely does seem to be a very good plan to rationalize those denominators first, to change them into nice fractions, right? Fractions with a rational number in the denominator, and then we're just adding together good old regular fractions, right? It's a lot easier. If we just employ the algorithm of adding fractions by kind of multiplying denominators together, we get an answer which has a surd in the denominator, and then when we try and rationalize the final answer, we go and have to do another few pages of work just to get to the same final answer. Okay, so that's a really interesting question.